Hello, math magicians. This is Mrs. Ross, and this is lesson 36, practice set and starred problems. So let's dive into it. A says, in the pond there were 240 little fish and 90 big fish. What is the ratio of big to little fish? So we're going to put it's big to little, which is 90 to 240. And then we're going to have to reduce this, okay? So I canceled my zeros, and then I'm going to divide by 3. Oop, there we go. And the answer is 3/8. That is my ratio. You can also write that 3:8 or 3:8 because this is a ratio. All right, let me change colors. And 14 of the 30 students in the class were girls. What was the boy-girl ratio? This requires an extra step. So if I have 30 total students and I have 14 girls, that means I have 16 boys. Okay, so boy-girl ratio is going to be 16 over 14. And I'm going to divide that by 2, which gives me 8 over 7. Now, I'm not going to reduce this because it's a ratio. Do not reduce. Okay, and again, it can be either 8 over 7 or 8 to 7, however you want to write your ratio. Okay, the team won 3/8 of its games and lost the rest. What was the team's win-loss ratio? This one's a little bit tricky, so I'm going to draw this out for you. So we have 1, 2, no, not like this, I'm not. Let me do a ratio box. Okay. So this is, nah, that's not gonna work either. I think I'm just gonna go back to what I was doing. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 3/8, 1, and that means that 5/8 were lost. So if I do a win over loss ratio, I'm going to put 3 over 5. That's my win-loss ratio, or you can do 3 to 5, 3 to 5, however you want to write it. Oh my. The bag contained red marbles and blue marbles. If the ratio of red marbles to blue marbles was 5 to 3, find the fraction, what fraction of the marbles were blue. So the ratio was 5, this is red, to 3 blue. Okay, so if I had a total of, then my blue marbles over my total would be 3 over 8. Yeah, that's probably the best way to do that one. Okay, what is the name for a list of all possible outcomes in a probability experiment? This is called a sample space. For example, if I ask you for the sample space for flipping a coin, the sample space is heads or tails, and you are done. Or the sample space for a dice, 1, 2, 3, 4, 5, 6. That's it. All of the possible outcomes. Okay? Okay. I've lost my mouse. There we go. A penny and a nickel are tossed in the air once. One possible outcome is H and T, H for heads, T for tails. Position of the penny listed first and then nickel. List all the possible outcomes, record the sample space and braces. So if I have a penny and a nickel, I could have heads and tails. I could have heads and heads. I could have tails and heads, or I could have tails and tails. These are all the possible outcomes that I can have for if I'm flipping a penny and a nickel, just once. So they want me to put the sample space in braces, which is like those sideways chocolate chips that we draw sometimes. So we have H, that's an H, T, H, H, TH, and T, T. And there's another chocolate chip. Okay, where am I going? There we are. Okay. A coin tossed and a spinner is spun. Use a tree diagram to find the sample space for this experiment. Tree diagram, not so much a fan of it. So I know that a coin can either be heads or tails. So let's say I can have heads 1, heads 2, heads 3. Or I can have tails 1, tails 2, tails 3. Those are all of my options with the chocolate chips. With one coin toss and one spin of the spinner in G, which is up here, what is the probability of getting tails and a number less than 3? Okay, so let's see how many of those we have. I'm going to pick a different color. So let's see, tails, so that crosses this out. So tails and less than 3, I only have 2 out of the total of 6. And then because this is probability, I'm going to reduce, and I have 1/3. Okay, and then this is I, and it says which sample space is a better way to show the possibilities of rolling 2 number cubes. Why? Use the better sample space to find the probability of rolling a sum of 7. So this is saying that if I have 2 dice, like if you've ever played Monopoly or something and you have 2 dice, these are all the possible outcomes. But the sample space 2 shows you the actual, there's 2 different ways to get the number 3, there's 3 different ways to get the number 4, there's 4 different ways to get the number 5. So sample space 2 is the one that's much more comprehensive. And I'm going to use this sample space to find the probability of 7. So let's see. I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have a total of 36 outcomes possible. And then I have 1, 2, 3, 4, 5, 6 possible ways to get 7. I'm going to divide this by 6 to get 1/6, and that is my answer. Okay, let's look at some starred problems. This is number 1. I must have copied this straight out of the book. Use the data in the table to answer what is the ratio of cities with more than 20 inches precipitation to cities with less than. All right, so let's see. So this is going to be more than 20, more, less, more, less. So we want a ratio of more to less. So I have 1, 2, 3, 4. And then I have 1, 2. Now I'm not going to divide this out and get 2 because it's a ratio, but I am going to reduce it so that I get 2/1, or you can write it 2 to 1, 2 to 1. Okay? Shannon swam 100 meters in 56.24 seconds. Rick swam 100 meters in 59.48 seconds. How many seconds longer did it take Shannon to swim? I think you guys can figure that out. If not, please let me know. In the following statement, change the percent to a reduced fraction, then diagram the statement. So let me go ahead and do this one for you. 40%, so 40 per 100, because this is the first thing I need to do, right? Let me reduce this. And then that tells me what my diagram's supposed to look like. So since I have 5 on the bottom, 1, 2, 3, 4, and 5. So I know 2/5 of the 30 players never played rugby. Never. And 3/5 played. So I have to divide 30 by 5 to figure out what goes in each of these boxes. And then let's see what the questions are. How many of the players never played rugby? So that's going to be 6 plus 6, which is 12. And then what is the ratio of those who played to those who did not play? So I know that not played is 12. I know that played is going to be 6 plus 6 plus 6, which is 18. And I want to know the ratio of played to not played. So that's going to be 18 over 12, and I'm going to divide by 6, which gives me 3/2, and that is That's it. We don't reduce further than that because it's a ratio. Very special. Okay, AB is 4 centimeters, and AC is 9.5. It says describe how to find this in millimeters. Now, this is centimeters and this is centimeters. So it's going to be 2 steps, and I think you guys can do that. Estimate the perimeter of this triangle by rounding each measure to the nearest 100 millimeters before adding. So the nearest 100, so this is going to be 900, 400, and 1,000. And you guys can do perimeter. Round to 3 decimal points. I'm going to go ahead and do this one. So let's see. This is the 3rd decimal point, so I'm going to look at this one. And it's not greater than 5, so this is 6.857, and that's my answer. And then it says estimate the product of this and this, round each factor to the nearest whole number. So I would round this to 7, and I would round this to 2, and then I would multiply. I'll let you guys do that one. In a probability experiment, a coin is tossed in a number cube. This is a die, 6-sided die. Make a tree diagram. I'm not a fan, so you'll see how I do this to show the sample space. Okay. So for a coin, I have heads and tails. For a dice, I have 1, 2, 3, 4, 5, 6. So I'm going to have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, and then I'm going to have tails. And that is my sample space. And then it says refer to the sample space to help you find the probability of getting heads in an even number. So that's like a part 2 here. So this is the part 1 is the sample space. Part 2 is the probability of getting heads in an even number. So that means that this is out, 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 out. So probability of heads and even is going to be 3 over, and then the total is 12. There's 6 here and 6 here. So let me divide by 3, and I get 1/4. All right, let's change colors again. Okay, find the length of this segment in centimeters and then in millimeters. So here I have 40, this is 10, oh, this is in millimeters, my bad. So this is 10, 20, 30, 40 millimeters, 41, 42. So this is 42 millimeters, and I know that if I divide by 10, I'll get centimeters. Okay. What decimal number names the point marked M on this number line? Okay, so this is 13.51, 13.52, 13.53. You can see where this is going. I could be a robot, and this is 13.56. That's the number you're looking for. Okay. There's a big star here. I realize it's not starred, but it looks like it should have been. So the first thing you have to do is you have to square 12. So I have 8y is equal to 144, and then you should be able to do this one. This one, since the variable is in the top, we multiply, and I'll let you do that one. These you can do with your calculator, calculator, calculator. Okay, and we're done. All right, let me know if you have any questions.